Okay. I would like to recall what we are doing. So we work on our homework and projects basis basic. So now we can do Nash equilibrium. We know how to construct utility matrices. We know how to download, and we have downloaded. We have rationalization. We have applied, or we some of us applied rationalization method, minimax equilibrium, Pareto, and we're like here. We're going to proceed with uncertainties. I would like to show some books about this problems in general. So the another name for these problems is location games on graphs, networks. Um, okay, and some interesting reading. So there is a book. Uh, it's rather fresh one. So sorry. It's can see date. So there are some description of games, such games. So it's second edition. Oh yeah, it's 2019, so only 2 years ago. There is problems. I would like to recall what Pymedian is. So if we have graph, and we are allowed to place only p stores such that a function like the sum of closest or the maximum of their so it may be the sum of all distances from points to the closest of this p stores, or it might be like a minus max. So it means that we want all points to be to be close to these stores, such that maximum will not exceed the value, such value, or we just want to minimize the maximum of such time for customers to get to our store. So it's been, so for example, we can place here one store here and the second. So we will have like 3 areas. Well, indeed, it will be some kind of Voronoi diagram here, if maybe you know this concept. It was introduced for plane. If we have several points, then we can construct here the structure that will show us areas of influence of each store. When here, Voronoi diagram. This one is well-known thing. We will have here something very similar, but the problem is where should we place these points, and there is a name, a Pymedian problem, but it's not for games, so it's usually for one player who has several shops. There are so Pymedian here is the sum, and p-center is max problem, as I remember. And they have several heuristics about this. Another book, maybe not so fun, is about it was the geography of competition. Race, yeah, and they have several algorithms and logistics and programming that we haven't discussed. Most of them, like Hitchcock-Koopman problem and other things, like here. So you can look at these problems. If you look at some, there are articles, rather fresh academic articles. So it's Italy and France 3 years ago about location games on networks. It's something that we do now. So they proved existence and deficiency when they have some assumptions. This problem has big history here. Another article is an idea of guys. They decided to use social media to solve. It's more about application of their problems. They have found data. I think it's like data. So it's a city, and these places are customer agglomeration. So in our problems, we had situation when we have like a uniform distribution of customers, but we might want to place customers in special areas, like these guys did, and then it's Chinese problem, and a Chinese article, and they have some math and feasible location for stores. So it's some kind of p-median problem on this graph. But they have special map here of roads and so on. It's a good idea how we can show the results of our optimization problem. Unfortunately, for data sets that we have, we usually don't have geographical attachment, but geomaps, I think that maybe there are data sets with not only graph, but with also points on the map. In this case, we can use Google or something to show in this case. It looks great, though in mathematical sense, it doesn't show us any very interesting thing. They have some sensitive parameter and so on. So very interesting paper from the terms of application. There is also Nash equilibrium in location game or network. It's just like it looks like what we do here, but we have uncertainties and some other things, and it's rather fresh. So it's only 4 years ago. Okay. There is also some kind of sharing games. I think we don't have this problem in our main part of our course. Sharing games or sharing model of aggregations. So the idea was that it's connected to logistics. So if we have a graph here, or we have a map, and some nodes are black, others are here red, white, and the idea is that if we consider it like a clusters of citizens of a city, like New York or any other city, it was a problem about rich and poor and black and white. division. So and when one guy he finds that his neighbor is not of the same type as he is, like he's very rich and he's in surrounding of very poor guy or otherwise, so he might want to change his place to another one, like here. This one will go here, and so on. In this case, we will have segregation there. It's a very old problem, but and it's like about logistics. So if you have such kind of clustering of customers of different type, it makes logistics more easy because we can use, or easier because we can use this for per median. Our areas becomes more convex here, and they use something very connected to this, like games of showing games on graphs, and they try to solve it. This article is also very fresh, so it's only 2 years ago. Yeah, it's something, but well, it's connected here. So there is a connection between location games and information diffusion games. So if we think about this as a graphs, plane, and look, if we talk about placing 2 or 3 maybe players, they place their shops here, 4 players, and we can divide by one diagram all customers between them, but we can well, we will have the same picture if we consider these places not as the spots where customers go, like here, but we can consider it like a information source. And in this case, if we have 2 sources of information, then we can consider guys who get information from the this source or this first, and we can we might want to find such a per center or per median solution for these problems to get the location of these points, such that we have for p center situation when we inform all customers or agents here in the fastest way. I mean social networks here, because if you talk about map, now we have internet, so it's very easy to